Okay. All right, well, let's pick it up. Let me get it started, and I'll do roll after I kind of get us going. I think that'd be the best use of time. So, okay. So, yeah, so now we're in the harder ones. And so, how do we solve those? Well, first off, whenever you have, let me just write it over here. Whenever you have x squared with an equal sign. We don't have x squared, we have cosine squared, but same basic idea. Whenever you have something to the second power, and what should you do about it? What should be the game plan? You kind of want to know this as you go forward, pre-calculus, maybe next semester. First off, you need to get a 0. You wear that game plan. That's pretty much always the game plan. I can't remember if we talked about it or not. But whenever you have x squared, you always want to get a 0, and then you want to factor, which means like, 2 parentheses kind of thing. And step 3, each part equals 0, because if two things are timesing to be 0, either one could be 0. So that means as soon as I look at this question, 2 cosine squared x plus cosine x equals 1. As soon as I look at that question, I should think, okay, there it is, second power, cosine squared, got to get a 0. So it's the same kind of thing. We're just going to do it with cosine that we normally do with plain x. So which means what? Step 1, get a 0. So let me bring this up here. So step 1 is I'm going to get a 0. How do I get a 0 on the right side? What am I going to do? Yeah, just subtract 1, or you could just jump the 1 over. Same effect either way. Just change the sign, huh? Either way you do it, you get minus 1 equals 0. Good. Just subtract 1 from each side, or either way. Okay, so that's step 1, get a 0. It's always the first step. Step 2, factor. So now I need to factor, and by factor I mean, the 2 parentheses. Got to find out what would multiply to be that. So we did this part. So how do you do this part? You just guess around till it works. There's really no magic formula. It's just you got to do this so many times that you can do it quickly. So 2 cosine x times cosine, the front times the front has to make the front. Good, I'm just thinking when I FOIL this out in a minute, boom and a boom, it's got to go back to this guy first. So 2 cosine times cosine is 2 cosine squared, right? So far so good. And then whatever goes here times whatever goes there, the right spots, the last spots in the parentheses, they need to multiply to be negative 1. How can they times to be negative 1?
Plus and minus.
Yeah, plus and a minus, huh? Plus 1, minus 1. Now, it matters which order, and that's actually the wrong order right there. How do I know? Well, because I'm foiling it in my head, because I've done 10 million of these things, and the more you do them, and probably some of you already can as well, but if you can't tell, you just got to FOIL it. And the more you do it, pretty soon you'll be able to do it in your head. So let me just do it. I'm just going to FOIL this out now to see if it's all right, meaning first to both, second to both, right? We call that FOIL, first, outer, inner, last, or double distribution, whatever you want to call it. First to both, second to both. Multiply it out. See if it really goes back to those 3 terms or not. It won't quite. The signs won't be right. Here we go. 2 cosine times cosine. Well, I'm just going to write C. 2 cosine squared. And then 2 cosine times negative 1. That's negative cosine, or negative 2 cosine, huh? Good so far? And then this guy is going to go to both. Plus 1 cosine, and then plus 1 times minus 1, minus 1. That's what? 2 cosine squared. What do these do? Minus 2 cosine plus 1 cosine is minus 1 cosine, isn't it? Right? If you lose 2 cosines and gain 1 cosine, you lost 1 cosine overall. Right? That good in the middle? Minus 1. Now, is that the same as this? Not quite. The sign in the middle is supposed to be plus cosine. I'm getting minus cosine. So what does that mean? Switch the signs, right? Switch the signs. Go back up here and go, okay, it's all good except that needs to be minus, that needs to be plus. And, try it again. Make sure. You want to be 100% sure. If you mess it up at this stage, everything else after that will be wrong. So let's try it again. So so I'm going to get rid of all this scribbling. Okay, so 2 cosine times cosine is 2 cosine squared plus 2 cosine, and then he's going to go to both, minus cosine minus 1. Is that right? Yeah, now plus 2 cosine minus 1 cosine is plus 1 cosine, or just cosine. Right, that's the middle term is plus. So check, yes, right, good, it's working. Make sense? See how I know I've got it factored correctly? I multiplied it out and it went back to the thing I had. So you got to do that. You got to be sure. You can't just kind of hope. You gotta know for sure. And you do this enough times, pretty soon you'll be able to do it with your eyes, just kind of looking at it, and you'll know whether it's right or wrong. That makes sense? That's the deal. Is that questions I can answer on that so far? So it's all factored now. I'm glad. Please ask. I'm glad to have. This is all the kind of stuff I want to help you with. I know it's all this little stuff that gets people, and no need for that. I can help you, and Roberto can help you. Get the help you need. All right. So let's keep moving now. So that's step 2, factor. Step 3. Now you set each part, meaning this part and that part, equal to 0. So 2 cosine x minus 1 equals 0, or cosine x plus 1 equals 0. Each part equals 0. Why? Well, because two things are up here, they're timesing, huh? Right? This is times. If something times something equals 0, if two things times to be 0, either one could be 0 to make them times and be 0, huh? So that's why either one could be 0 to make that true. And then you just solve each one separately. So how do I solve this one here separately? You know now. Now that it's just regular cosine instead of cosine squared, it's not too bad. We can do each part separately without too much trouble. Move that over to cosine is positive 1 or regular 1, you know. Divide by the 2. So cosine is a half. Let's go over the other side. Move this over. Cosine is negative 1. So now we're almost there. It's come down to, this is probably where we stopped last time, is that right? Or sort of. So now we got to solve this, and we got to solve that, which is like 2 of the problems we did, last week, huh? It's 2 of the easy. It's basically come down to 2 of the easy ones, two of these now. So all that work that we just did was the new stuff. Now we go back to the old stuff and go, okay, how do you do cosine equal to a half? What do you do? Well, you draw the unit circle. Let me squeeze it in over here. Yeah, good idea. Okay, let me go over here. And say, okay, so cosine, draw the unit circle. And you want to find the two places. Remember, there's always 2 places. Can you find the 2 places where cosine's a half? And then over here on the other side, you're going to draw a unit circle and find the 2 places. Remember, there's 3 dots in each quadrant, right? And you remember the whole small, medium, large thing? Right over here as well. 3 dots in each quadrant. And you're thinking small, medium, large. And actually, when you have this one, negative 1 or positive 1, or 0, that's going to be one of the axis points, isn't it? One of the grid line points. That's either going to be here, or here, or here, or here. It's not going to be those other spots. Because the negative 1 is not small, medium, or large, right? Remember the small, medium, large are a half, root 2 over 2, root 3 over 2, small, medium, large. So the negative, whenever you got a negative 1 or positive 1 or 0, that's not one of those small, medium, or large. So that means it's always 1 or 2 of the axis points, isn't it? For 0, 1, or negative 1. But if for the other one, for this half, this is the small value, huh? So there should be 2 dots coming out of this one, 2 dots. And there should probably be just 1. Yeah, just 1 dot on that one. Find those. All right. So how y'all doing? So let's see. So this is a half. This is small. Is cosine x values or y values? X. Cosine is x. Sine is always up, down. Y values. Cosine is always right, left, x values. So we're basically saying x small values. So, and that's positive, right? Positive half. So which of all those? So first off, x is positive. So it's on this side, isn't it? It's on the right side. Because that's where all these dots are positive x values, aren't they? The dots over here, this is negative x values. These are positive x values, right? Because here's the x-axis, right? Here's 0. Positive to this side, negative to that side, huh? So all the dots to the right are positive. So and this is positive. If this was negative a half, then I would be looking on the left side. But it's positive half, so I'm looking on the right side, aren't I? So it's among those 6 dots. Which of these 6 dots then has a small x value, is over just a little bit? This one and this one. Those are both over the least amount, aren't they? Whereas this one's over medium, this one's over a long ways, right? So it's those 2 dots. What are those 2? Well, this is 90 right here, so this must be 60. This is 270 right here, so this must be 300 on that. So there's my 2. I can turn them into radians in a minute, but there's my 2 angles where the cosine is positive a half. Is that good? You comfortable with that? I'm glad to spend some time with you. Office hours 12 to 1 today, tomorrow, and Wednesday. If you're having trouble with that, make sure you get that down. Next Monday's our test on that. And that would be death to not be able, well, that isn't death, but that would be death on the test. Because there's going to be a million of those. There's just going to be tons of those. Got to make sure you can draw those unit circles and do the small, medium, large. Won't take long. Get me or Roberto, get some help. All right, where's cosine -1? So that's, again, x value. Which of these 4 dots have an x? We know it's not a small, medium, or large, so it's one of the 4 axis points, or maybe a couple of them. Which of those 4 axis points have x values -1? This one, huh? This one right there. He's that point is back 1 up 0. His x value is -1, his y value is 0. He has an x value -1, doesn't he? Cosine is always your x value. Sine, if I was asking sine, that'd be a different story. That'd be your y value. All right, so it's that dot's 180, isn't it? So that's 180. So 180, 300, and 60 are the 3 angles, right? The 2 angles that make this one true are 60 and 300. The only angle that makes this one true is 180. So those 3 are all answers to our question. Do you see how they are? Right? Because 360, sounds like I'm saying 360, 360, those 2 angles make cosine a half, which means they make the left guy 0, which means anything times 0 times anything makes the equation 0, makes the equation true. And 180 makes the right guy 0, because it makes cosine -1. At 180, cosine's -1. If cosine's -1, -1 plus 1 is 0, and these guys multiply to be 0, and that equation's true. So those are the 3 places that make this trig equation true. Now here's the nice thing. I don't need to do the plus 2 in pi. Why do I not? How do you know? I remember as I reviewed this stuff last week or the week before, I was like, when do you need to do the 2 in pi and when do you not? So I got that straight. Let me mention it to help you. When they say only 0 to 2 pi, see they said that right here. Let me get this out of the way. Up here, they said only give us answers 0 to 2 pi. But that's not the whole story, because it's a little more tricky than that. When they say only 0 to 2 pi and no 2x or 3x, etc. in the angle, then skip, let's just say, then skip the plus 2 in pi, 2 in pi for sine or cosine, and plus in pi for tangent. Remember how tangent or cotan have in pi instead of 2 in pi? Remember how we talked about that? So does that make sense? Really make a note of that. That'll really help you. You're going to want to have that in your 3x5 card and just be real clear. Because it gets a little confusing. Like, when am I supposed to do the 2 in pi? When am I not? Now, you might think, well, it's just, I thought at first, because I hadn't done these problems for years, when it's the first time I taught trig in 10 years. Anyway, when I looked at that, I thought, well, if they say 0 to 2 pi, they just want answers between 0 and pi. I don't need to do the 2 in pi. Well, no, actually, even if they say that, but they say the 2x or 3x, the multiple angle thing, and we did a couple of those, then you still have to do the 2 in pi, because it can do a tricky thing. Anyway, I don't got time to explain it all. Let's just leave it at that for now. So everybody getting the idea. When can you skip the 2 in pi thing? If they only say 0 to 2 pi and it's not multiple angles. You know what I mean? In other words, this is just regular x, regular x. It's not cosine 2x or things like that. Remember, we did some of those last week. Those are more tricky. You got to do the 2 in pi for those. Or, yeah, so if they just say we only want answers between 0 and 2 pi, that's all we want, answers between 0 and 2 pi, and they don't have a 2x or 3x, then you can skip the 2 and pi thing. So I can skip it here. So my answers are basically done. Let me just get this out of the way here and write the final answers. We are done with this problem. I just got to change those to radians and we're out of here. So I just erased part of the answer, huh? All right, so what are my answers? This is 180 here. So my answers are 60, 300, 180. Those are the three, and I just got to change them to radians and we're done. Don't need to do any 2 and pi's or any other fancy stuff. So 60, remember what you do, you just multiply each of these by pi over 180. That's going to be pi over 3. 300, same thing, times pi over 180. What is that, 30/18 pi divided by 6? Is that going to be 5/3 pi? And the third answer, oh, that's easy, 180. That's just pi, huh? So there's the three answers. They want you to list them with commas. Pi over 3, 5 pi over 3, and pi. Is that good? Let's go back and do it. Make questions I can answer on that. Is that good? All right, that's number 1. Let's move on. So let's try one. Okay. Can y'all see that? Let me write it up top here, a little bigger. 5 sine squared x is 13 sine x minus 8. All right, try that one. So you see sine squared. What's the first order of business? Get a 0, right? Whenever you see anything squared, x squared, sine squared, cosine squared, whatever, you see this second power right there, you say, oh, with x squared or anything squared with an equal sign, number 1, get a 0. Number 2, factor, which means the double parenthesis thing. Number 3, after you factor, you set each one equal to 0, because if things times to be 0, either one could be 0. So try that, start rolling that out. That's a 5 in the front. It looks like a big S. So that one's going to be hard to factor. Really important that you practice that factoring. See if you can get that. Feel free to check with those around you. So we grab the 13x, jump it over, the minus 8, jump it over. So we get 5 sine squared x minus 13 sine x plus 8 equals 0. So far, so good. Right? They change signs when they jump over. Chanu?
Can you just put minus 5 signs to the other side?
You could, yeah, good question, Chanu. That's hard, though. I mean, you totally could. There's nothing formally wrong with it. It's more difficult, though, when you factor with the parentheses, to have the front one negative. Because if it jumps to the other side, it'd be negative 5, like you were saying. That's hard. So, yeah, good question. I didn't think yours. I would suggest you jump it doesn't matter right side, left side, all that's fine. It'll be easiest to jump whichever way so your front one is positive. That's just easier on the factoring. If you have a negative in the front, it's kind of hard to get all that straight. So I would suggest, either one's fine, but I would suggest it's going to be easier for you to move everybody to the left on this one, because then your front one, this guy, is positive. And that's easier to factor if he's positive. So go ahead and take it from there. So now you're looking for the 2 parentheses, right? Now you're looking for 2 parentheses with an equal sign there. And they have to multiply to be this. So let me give you a minute on that. I know. So yeah, if you're looking at that and you're like, well, I have no idea. Well, you know at least how to get 5 sine squared, right? Front times front to make front. right? Because you guys know we have a front and a back for each of the parentheses, right? And when you FOIL it out, which we're going to do in a second, front times front needs to make front. Remember that with FOILing? So what times what will make 5 sine squared? 5 and 1, huh? So it's got to be a 5 sine and a 1 sine, or just regular sine is fine. Good so far? And now you say, okay, back times back to make back. The middle's the hard part, huh? You can go front to make front, back to make back. What times what makes 8? Well, a lot of things. 2 times 4, 1 times 8. Well, 2 things. So, which of those is right? I don't know. Got to try stuff. Try stuff. So it won't do any good staring at it. I remember working with my girls on this, a couple years ago when they were taking trig and pre-calc and stuff, and I remember them both saying at different times, "I hate factoring. I understand, but you just got to push through it. You just got to do something." So if you look at this thing, I don't know, put a 2 here, put a 4 here, and try it. FOIL it out. Just see what happens. Put a plus. It's got to be plus and plus to make plus 8, right? Plus 2 times plus 4 to make, and then try it. Is that right? Boom, boom, here we go. Is that right? I'm just going to use S, save time. 5 sine squared plus this times this would be what? 5 sine times 4 would be 20 sine, and then this times this would be 2 sine plus 8. 20 plus 2 in the middle is 22. That's not even close to negative 13. No way. It's not 2 and 4, huh? Not only that, how are you going to make the middle negative? Yeah, these guys got to both be negative. So at least if I'd made them both negative, this is still going to be plus 8. In fact, negative times negative makes positive 8 at the back. It still makes the 2 negatives multiplied to be positive. But that way, at least the sign in the middle will be negative. But it's still way off. Okay, now it's negative 22. It's still way off of 13. So what? It's not 2 and 4, is it? What is it? That's going to work. It's got to be 1 and 8. Yeah, so try 1 and 8, but the order matters. 8 and 1 is different than 1 and 8. You got to try both and then FOIL and see which one works. So I don't want to go ahead without you there. So, and they both got to be negative. We already decided they both have to be negative, huh? Because that way they will multiply to be positive at the back and yet still make negative in the middle, huh? So let's FOIL it. Here we go. Boom, boom. What's that? 5 sine squared minus 40 sine, boom, boom, minus 1 sine plus 8. Look at that, minus 41 in the middle. Not right. That didn't take me long, right? So I know that's not right. Everybody good there? So what do I do? To fix it? Flip it. Swap the order, huh? You swap the order. See, there's a lot of swapping the order on the back, too. Now try it again. See if this is right. Go. Boom, boom. That'd be 5 sine squared minus 5, right? 5 times negative 1. And then minus 8, boom, boom. Minus 8, sine, plus 8. Negative times negative, plus 8. See what they make in the middle? Minus 13 sine. Beautiful. There it is. It's factored correctly. Does everybody see that? And the more, I know that feels tedious and like a lot of time, but the more you do that, force yourself to do that, pretty soon you'll be able to see them. You won't have to do that out all the way. That's how it works for everybody. You got to do hundreds of them, though. And after a while, you can start to see it happening. All right, so it's correct. It's factored. That's step 2 is to factor. Step 1, we got a 0. Step 2, we just factored. Now take it from there. Step 3, you set each one equal to 0, right? Because they're timesing to equal 0. So either one could be 0 to make that true. So solve each one alone. So 5 sine minus 8 equals 0. 1 sine minus 1 equals 0. We good to there so far? And then just solve each of these little equations separately. So I'm going to move the 8 over. 5 sine is 8. Divide by 5. Hit the buttons on your calculator. What is that, 1.3? On the other side, move that over. Sine is positive 1. We good so far? Questions I can answer? Now, now we're ready to do the unit circle thing for both this. All right, here we go on this one. I'm going to draw the unit circle. That's a weird number, huh? 1.3?
It's illegal.
Yeah. We haven't had that's not one of my small, medium, large. It's not a half or root 2 over 2 or root 3 over 2. It's not even 1, -1, or 0, which means one of the 4 axis points. Well, what is it? 1.3? It's too big. Sine can never be bigger than 1. There's no answers out of this one, right? Sine never equals more than 1 or less than -1. Remember the graphs of sine and cosine? The highest they go is +1, the lowest they go is -1. There's no angle whose sine is 1.3. If you do inverse sine of 1.3 in your calculator, it'll tell you air. So you can never get a value higher than 1 or lower than -1 out of sine or cosine. So sine is never equal to more than 1 or less than -1. So that's just a throwaway. There's no x's that make this part true. So there's no answers out of that part. Let's go to the other part. Where is sine equal to +1? Well, you know that's going to be 1 or maybe 2 of the 4 corner points, because again, that's not one of my small, medium, large. That's 1. So where is sine? Sine is always the y value. Which of these 4 dots has a y value +1? This guy up here, right? Because that's over 0, up 1. X is 0, y is 1 at that dot, huh? Good. That's the y value. So that's what? 90 degrees, huh? So 90 degrees times pi over 180 is 90 over 180 pi, or pi over 2. That's my only answer. Pi over 2. Don't need to do the +2 in, do I? Or do? Let me go back. It said 0 to 2 pi, and there's no multiple. It's just regular x. So remember, if it's just regular x, and they only said give me answers 0 to 2 pi, answers within 1 rotation, then you don't need to mess with the +2 in pi thing. If they do either one of those, if they say, no, give me all answers. Remember how they said that in last week's one? They said, give me all answers. They mean answers even beyond 1 rotation. So I had to do the +2 in pi if they say, give me all answers, instead of just answers within 1 rotation. Or if they have a 2x here or a 3x, or something like that, then you automatically have to do the +2 in pi, even if they said 0 to 2 pi only. So anyway, they said neither of those. We're good. We're done. Pi over 2. That's all. Okay? We good? We got 14 more. We better move. But you feel free to stop me, though. So I'm feeling like hitting the gas and accelerating because I need to get through 14 more. But I don't want to leave you behind. So they're all just a little different. Okay. 8 cosine squared minus 2 equals 0. Yeah. Yeah. How should you do that? Yeah, let me mention, when you have x squared or cosine squared or whatever, with an equal sign. Now, I just gave you instructions. So I said, hey, get a 0. Well, that wasn't the whole story. When you have x squared with an equal sign and no x to the first. See how we don't have regular cosine anywhere? We only have cosine squared? See, that's different. Look back here. See how we had sine squared and then regular sine? Or the one before that. Here it is. Cosine squared and regular cosine. Yeah, so when you have sine squared and regular sine, or cosine squared and regular cosine, yeah, you got to do the whole thing I told you about. The equal sign, you got to get a 0, factor, each one is 0. Yeah, you got to do that whole thing. But if you just have x squared and no x, like this one, we just have cosine squared and no regular cosine anywhere, there's an easier way to go. Just get x squared alone and root plus or minus root. Remember that? You don't have to work so hard with factoring and zero and all that stuff. If you just have cosine squared, not regular cosine, or just sine squared, you don't have regular sine, just get it alone. So this is easier. So just move this over there. 8 cosine squared is 2, positive 2, right? When that negative 2 jumps over. See how I'm giving you a recipe for every different type? See how the battle will be next Monday on the exam is to have these different instructions written down in your 3x5 card and have practiced the homework and the practice exam so many times that you look at something like that and you go, oh, cosine squared, not a regular cosine. I remember you don't have to do the zero thing. You just get it alone. You know these processes. That's it. That's why it's just practice. All right, so solve here. So divide by the 8. And so that means cosine squared is 1/4, isn't it? Good to there. So what I'm saying is when you just have x squared and not regular x, you don't have to work so hard. Just get it alone. And then what do? You put a root on one side and a plus or minus root on the other. So I got it alone. So now I'm going to put a root on this side and a plus or minus root on the other side. Right? Because something squared could be positive or negative, and squared it'll still be positive 1/4, won't it? So that makes sense. That's why we got to do the plus or minus. So rooting cancels squaring, right? You remember that from algebra? So that means cosine is plus or minus, and what's the square root of 1/4? It's a half, huh? Right, square root of 4 is 2, square root of 1 is 1. So I square root the 1, it's 1. Square root the 4, it's 2. And the root's gone now, huh? When you root something and it does its job, then it leaves, doesn't it? So there's no more root. I did the rooting. It did its job and it left. So cosine, regular cosine, the root canceled the square. Regular cosine is plus or minus a half. So what do I do with that? Just break it into 2, and solve them both. So I'll just say, okay, cosine is positive a half, or cosine is negative a half, and just do the unit circle to solve for each one. Is that making sense on that? So we didn't have to do the zero factoring. Why not? Because we just had cosine squared. We didn't have regular cosine. Those are easier. So let me let you finish. So do the unit circle thing. I just want to let you practice that. Do the unit circle for both those. So this is the small, medium, large thing. Cosine's always the x value, and it's positive. So we know it's over here, right, where the positive, it's one of those two of those 6 dots, because it's a positive x value. It's to the right, and then this one is negative, so it's going to be to the left. It's 2 of those 6 dots on the left side, isn't it? All right, so which 2? Well, it's the 2, let's do this one first. It's the 2 x values that are small. Which of those 6 dots, which 2 have the smallest x value? It's this one and it's this one. They're both over the lowest amount, aren't they? Does everybody see that? They're only over a little, up a lot, aren't they? So both those are over a little, up or down a lot. So what is that? That's what, 60? And this one is just past 270, so it's 300. We did that a minute ago, huh? So 60, because it's 90 straight up. 60 and 300. Over here, it's this dot and this dot, which is just past 90, so it's 120. This is just before 270, so it's 240. Is that too quick? Is that okay? Everybody see that? Is that too sloppy? I want to make sure. Here, let me rewrite that. It's kind of messy. Do that a little more slow. Because I want to make absolutely sure y'all can do this, because you won't be able to solve any of these if you can't do this. So cosine is positive a half. No, negative. That was the negative side, huh? So, and I right away knew that it was going to be on this side because it's negative x value. That's to the left. And which of those have the smallest x value negative? This one and this one, right? They're back just a little bit, aren't they? They're back a small amount, up a lot, back a small amount, down a lot, aren't they? Those are both back a small amount. Negative is back a small amount. Okay, and what is that? 90 straight up, so this one must be 30 off of that. 120, it's 30 off of 90. And straight down, you know, is 270, so this must be 240. So our four answers are 60 and 300, 120, these are all degrees, and 240. Those are our four answers. We just got to change them into radians. Can I just go dot, 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 and move on with something else? Just change them now to radians, and you've got them. You list them in any order with commas. Those are the four answers. We don't have to mess around with 2 and pi, again, because they just said, give me answers between 0 and 2 pi, and there was never a 2x or a 3x anywhere. So we can just leave it like this. We'll change the radians, and we're done. Is that good? You okay on those? Hardest section in the course. So hopefully if you're doing good here, you can do anything in this class. Unit circle stuff. Yeah, I need to or I won't get through this. Okay, gonna have to. So 2 secant squared x minus 4 equals 0. As soon as you see secant squared, what should you think? 1 over cosine squared, huh? Well, actually, first get secant alone. But then once you've got secant, flip both sides and say that's cosine. Right? Does that make sense? So go ahead and solve. Just go ahead and solve first off. So get secant alone. Let me let you do that. Just forget about the secant cosine thing for now. Just can you get the secant alone first off? It's just like the last one, right? Because we have secant squared and we don't have secant to the first. So that means just get that secant alone, secant squared alone, and root it. Root on both sides. All right, so again, it's secant squared, no secant to the first. So just get it alone and root plus or minus root, huh? That's what we're thinking. If there was secant squared and a regular secant, say this was 4 secant, then I would do the get a 0 factor thing, huh? Everybody got those two techniques? If you got secant squared and regular secant, that's get a 0 factor. If you just have secant squared, that's just get it alone and root it, plus or minus root thing. All right, so just get alone, so move the 4 over like that. So 2 secant squared is positive 4 divided by 2. So secant squared is 2. Good so far. And now I got it alone. And now you put the root on it. Root, and plus or minus. Rooting cancels squaring. Rooting is the opposite of squaring, cancels it. So you get regular secant is plus 2 or regular secant is minus 2. You got the two different answers? Good so far? Now, we got to turn secant into cosine. Remember, secant is upside down of cosine? So if secant is 2, that means cosine is a half.
Why are you squaring the 2?
Oh, yeah. Yes, I messed up. Thank you. Yep, I'm all wrong there. Yeah, it just says root 2, huh? Not plane 2. Good. I was testing you. Good job. Good job. I was messing up. All right, so plus or minus root 2. We good? Yeah, it just stays there. I'm just like getting rid of that root for no good reason. The root needs to stay there. Now, flip it. And so how do you flip that? Well, just, positive 1 over root 2. This is, I was supposed to do the two different ones, huh? So this will be plus and this is minus flip it, and it's minus 1 over root 2. Good to there? Good so far? Now, that looks weird. I mean, but remember how we fix it? We never leave a root on the bottom. Remember, never leave a root in the bottom. So fix that. And multiply top and bottom by root 2. And what is that? Root 2 over 2. That's the medium. Now it's looking normal. That's the medium. Same thing over here. Multiply by root times top and bottom by root 2 over 2. And you get negative root 2 over 2. Negative the medium, huh? Good on that? So then, last step, unit circle time. So unit circle over here. Where is the cosine positive? Come on, screen. Positive the medium. That's what this means. Medium. So first off, positive. So that means it's on the right side. Right? So those 6 dots on the right side. Which of those are over medium? Well, right in the middle, huh? Right in the middle, right in the middle. Those 2 dots. 45 degrees for that one. And what's this one? Well, this is 270. Add 45, because it goes halfway to the middle. That's 315. So this dot right here is 315 degrees. It's 270 plus 45. Those 2, and then that's from this. Those are the 2 answers that come out of that guy. And then the other guy, this right side here, he has 2 answers from the unit circle. And they're both negative. So they're on the left. And medium. So medium left, medium left. What are those? Well, this is 90. And then add 45. This is 135. See how I got that? 90, add 45. This one is what? 180. Add 45. This is 225. So 225, 1/3. So what are all the answers? It's these 4. So right, everybody see the answers? So the answers are 45 degrees. Oops, I'm getting scribbly. So the answers are 45, 315, 135, 225. Those 4 answers. You got to change them to radians. Those are the answers. We good? So 2 positive medium, 2 negative medium. Basically all 4 medium spots around the circle are answers. And we're done. Questions? All right, so we have 2 cosine minus 1 times 2 sine minus square root 3. And so that's already, they're like halfway through the factoring. They've already got the parentheses, the 0. So you just say, okay, great, thanks. You just set the first one equal to 0 and then the second one, right? Because if 2 things times to equal 0, either one could be 0 to make that times and be 0, huh? So then just solve each one separately. Bump the 1 over. 2 cosine is 1. Divide by 2. So cosine is a half. Bump this over. 2 sine is root 3. Divide by 2. Sine is root 3 over 2. And then I'm going to go da-da-da, do the unit circle, do the unit circle. I'm going to move on. Good there? Just solve both those, and away you go. It was like already half done for you. Well, a fourth done for you. It was already factored. Got that down good enough? I better. Okay, so sine plus 2 sine cosine equals 0. All right, let me just let you try. Any thoughts what we could do with that thing?
Factor.
Factor, for sure. Good job. Now, what do they both have? Sine. That's like the GCF, what they have in common, greatest common factor. GCF. Yeah, just take out a sign. So this is just a one parenthesis factor. You know what I mean? Because you're looking to say, hey, they both. Those are the two terms. That, by the way, that's how you should be looking at it. Pluses and minuses are the separators, right? So you should be saying that's one term, and that all is a second term, right? Two terms separated by pluses and minuses. What do those guys both have? Sine. So you put the sign in the front, one set of parentheses. You know what I mean? That's just to take out what's in common factoring. It's a little easier factoring. And then say, okay, sine times what plus sine times what will go back to be the way it was originally. That's what factoring always is, right? Is reverse multiplying. Just saying what would multiply to go back. That's factoring. It's just reverse multiplying. So sine times what would go back to plain sine? It's 1, huh? Sine times 1. Good so far? And then sine times what here would go back to 2 sine cosine. 2 cosine. Right? Sine times 1 would be sine. Sine times 2 cosine would be 2 sine cosine. Good? So now you're at the factor, and you have two things times need to be 0. You know what that means logically? Either one could be 0. Right? So now set each part, set the sine to 0. Right? So now we say, okay, that means sine is 0. Or 1 plus 2 cosine is 0. Good? Because if two things times to be 0, either part could be 0 to make them times and be 0. Right? So this one's ready for unit circle. This one, got to finish getting it alone. All right, can you finish getting that one alone? Then you can do unit circle for that one too. Jump the 1 over. 2 cosine's negative 1 divided by 2. So cosine's negative 1/2. So that's unit circle time there too. So this is negative small or back, right? So which two dots are back the small amount? This one and that one, huh? So that's what, 120 and 240. Way over here, sine is 0. Now remember, 0 or 1 or negative 1, that's an axis point, huh? So where is the sine? What among these 4 dots on the 4 corners, the 4 axis dots, which of them have a sine, which means y value? Don't be thrown off by that x, whatever. Sine means y value, doesn't it? This is just like theta, really, you know. Sine of, so where is a y value? Which of these 4 dots has a y value of 0?
0.
This one and this one, huh? They're both at a height of 0, a y value of 0. So that's 0 degrees and 180 degrees. Good? Getting the hang of this whole thing? So what our answers are these 4. Change them into radians, we're done. Because again, they just said 0 to 2 pi. There was never a 2x, it was just plain x everywhere. So no more is needed. No 2 in pi's are needed. Ajane.
How come for the plus 2 sine x and then cosine x, you got 1 plus 2 cosine x?
Oh, yeah. Yeah, I was factoring there. So in other words, I was saying what would multiply. So yeah, good question. I'm sure other people are wondering that too. If I was to take this and multiply, let's just multiply it out. Maybe that'll help. What would sine times 1 be? Well, that'd just be sine. Anything times 1 is just self. And what would sine times 2 cosine be? It would be 2 sine, cosine equals 0. See how this went right back to that?
Yeah.
So that's what I'm doing. I'm just, that's what factoring is unmultiplying. Good question. Is everybody good on that? I just looked and I recognized that I could factor it, that they both had the same common piece. I said, look, they both, whenever you have two things like that that have something in common, you can take that out. It's called the GCF. Remember that from algebra factoring? Take out what's in common and do the one parenthesis. Notice this is one parenthesis as opposed to back here. See, this is two parenthesis factoring. Or, what just happened? Stop it. This one, too. Where is it? I've lost it now. This one is two parenthesis factoring. That's a little harder, huh? That's the whole FOIL thing. So there's two different kinds of factoring like that. So this is the easier. This is just take out what's in common, one parenthesis factoring. Good. Other questions on that one? All right. Okay, so 2 cosine squared plus sine equals -1. Yeah, this is where we start seeing why I'm saying this is the hardest section in the course. So these last, we're at about the back half almost of the hard ones, and this is where they'll start picking up. So you can't have a mix of cosine and sine like that. When sine, cosine mixed, replace sine squared equal 1 minus cosine, or cosine squared is 1 minus sine squared, to make all the same trig. Well, to make all the same. Let's just, to make all the same. Does that make sense what I'm saying? Remember the old formula that said sine squared plus cosine squared is 1? Remember that one that we had? And I said that's a big one. We're going to use that a ton. Remember, if you move either one to the, like if I move the cosine over, then that says sine squared is 1 minus cosine squared, huh? Or vice versa, if I move the sine squared over, same thing. So what that means is, anytime you see sine squared, you can replace it with 1 minus cosine squared, or vice versa. Anytime you see cosine squared, you can replace it with 1 minus sine squared. So what I'm saying is, when I look at this question, this is what needs to flash in your mind. You need to look at this thing and go, oh, he's got cosine and he's got sine. He's got them both. I don't want that. That's a pain. Got to get it all sine or all cosine. I don't want to mix. Now, there's one exception. Back you might go, yeah, we had right here, we had a mix, and you didn't do that? Yeah, it's because it was factorable. I just saw right away they had something in common. So this is what's hard about this. There's going to be different looks, and it really takes time. You're going to have to really spend hours of your life. This will not come. This will not come to the casual, this section especially. This is where I would spend hours of my life doing the problems over and over and over again until I recognize them. So because there's subtle differences. They're not obvious. So as you look at this, yeah, this one has a mix, but I recognize they had something in common. See, there's nothing in common here. So look at this. This term and this term, what do they both have in common? Nothing. So I can't do the factoring thing. So see, I'm looking for different marks than I'm used to seeing through hours of doing these. So I'm looking, going, yeah, they don't have anything in common, so that's always the first thing. That's what I did here. They already had something in common, so I did that. That's cake. If you see that, do it. Jump on it. Back here, you think, well, they had them here and you didn't do it. Yeah, it was already factored. And they already had the 0. It was like ready to go. So I didn't have to do any messing around. But here, it's not factored. There's no parentheses right now. There's no parentheses. It's not factored. I got to factor it. And they don't have anything in common. So I got to do something. There's a problem. I got to do something about this. I got to get it to all be sine or all be cosine. Do you see the marks I'm looking at, which are directing my thinking? It's not already factored. There's no parentheses, and it can't be factored. I mean, how would you factor this right now? These guys are totally different. They have nothing in common. So you got to do something about that. You got to get it all sine or all cosine, and then factor. How do you do it? You go, oh yeah, I remember the trick. Whoops. Erasing everything. The cosine squared right here can be replaced. What is cosine squared equal to? 1 minus sine squared. So make this 2 make this 2, 1 minus sine squared. What was that here? It was plus. Plus sine x minus 1 equals 0. And then that 2 distributes. 2 minus 2 sine squared plus sine x minus 1 equals 0. You guys tracking with me? Now what? That's a mess. Well, it's combined like terms. 2 minus 1 is 1. Good. 2 minus 1 led to just positive 1. Good. Just combine, subtracted the numbers. So now we're to here. What in the world should we do at this point?
I moved the 1 after sine x. Just
Okay. The main thing you want to think is, remember, I know I've said a million things, but I did say something about, this guy's the leader. He's the most powerful term. Focus on him, right? He's the leader. And we don't like him to be negative. It's just a pain. So I'm going to jump everything to the other side so he'll switch signs. Or you can just multiply through by negative 1. Either way, same effect. Does that make sense what I'm saying? Everybody here, I know I'm saying a million different things. That's why it says it doesn't come to the casual. You got to spend hours thinking about all these different rules and how they fit together. This is the front term. He's going to be the front eventually, because he's the most powerful term. And you can leave it, but it's really hard to factor when the front term is negative. You'll find it easier to jump it to the other side or just multiply through by negative 1. Either way, same effect. Making him positive, right? You want that front term to be positive. So I'm just going to jump everybody, whatever. You can multiply by negative 1, same thing. So now 0 will be on the left. It'll be positive 2 sine. All the signs will switch. Minus sine x minus 1. Now I'll factor that. So you can multiply through by negative 1, same effect. Either way, make that front one positive. It's easier to factor that way. Now do the double parentheses. Now that it's all sine instead of a mix, and the front one's positive, we got our 0. Now we can factor. Let's go ahead and factor that one. And I'm running out of time, so I'm just gonna do it quick and then go dot dot dot. Well, let me let you factor, and I won't do any more after that. I really want to make sure you're good at factoring. I know that's hard for people. So factor that one. So you got to FOIL it. So write out, take a guess. Write out what you think it is. Don't just stare at it. That won't help anything. Just take a guess. Write anything down, and then FOIL it. Multiply it and see if it's right. You'll learn. You'll begin learning immediately when you multiply it out. You'll start seeing. And your guessing will improve dramatically. So 2 sine and sine. That much has got to be right. We good there so far? It's got to be 2 sine times sine. Good to there. 2 sine times sine is 2 sine squared. Right? Front times front to make front. And then last times last to make last. What times what makes negative 1? Well, positive 1, negative 1, but maybe it's the other order. No, that's actually right. But the only way you're going to know is if you FOIL it out. So that makes sense. I made front times front, front, and last times last to multiply to be last. And then you just FOIL it. You just go, okay, here we go. I don't know. Let's see. Boom and a boom. What do you get? 2. I'm just going to go with an S. 2 sine squared minus 2 sine, and boom and a boom, plus 1 sine minus 1. What's that middle there? it's minus 1 sine. Oh yeah, that's what I want. Beautiful. That's it. See how that works? You just try something and FOIL it out. See if it's right. You just keep tinkering with it and foiling it, changing it, foiling it, changing it, foiling it, until it's right. And you'll learn. You'll learn so much as you do that. But you won't learn anything if you don't FOIL it out. Nothing, no learning will happen unless you're foiling it out. You just got to keep foiling. The more you see how the foiling plays out, pretty soon your mind will grab it and you'll know right what to write right there. That's what it takes, is lots of foiling. Okay, so, and now you know it from here, right? Now I'm going to say now the first one, 2 sine x plus 1 equals 0, right? Or the other one, sine x minus 1. You set each part, this part, equal to 0, here, then jump it over. 2 sine is negative 1 divided by 2. Sine is negative a half. Move it over. Sine is positive 1. And then do the unit circle, da, 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 da. I'm going to move on. Rudy.
What happened to the cosine? What did you do with the cosine?
Yeah, the cosine right here, I replaced it with this 1 minus sine squared.
Oh, that's right.
Really good question. Yeah. Everybody good with that? That's what happened, right? So remember that. We're going to do that trick a ton in the rest of the class. Sine squared can be replaced with 1 minus cosine squared and vice versa. Cosine squared can be replaced with 1 minus sine squared. We'll do that a lot. And then we did that to get it all be sine because we didn't want to mix. All good? All right. Any other questions? So try that one. Do the first step. Let me write it up here. Sine squared x minus 6 cosine x plus 6 is 0. So do that first step. You see, oh, can't have a mix, can't have sine and cosine. Replace that sine squared, get it out of there, and put in its place 1 minus cosine squared, right? Then it'll all be, how do I know that? Then it'll all be cosine. You're always replacing the squared piece, not the first power piece. The first power piece has to stay. There's no formula for replacing plain cosine or plain sine, but there is a formula for replacing sine squared, 1 minus cosine squared, or vice versa, cosine squared with 1 minus sine squared, right? You replace the squared piece, always, not the first power piece. So this is 1 minus cosine squared. That good to there. So sine squared is replaced with 1 minus cosine squared. Now it's all cosine, huh? So that we can do. So take the next step. You know what to do, right? Combine like terms, and you don't want that. Who's the leader there? Who's the one that's going to be in the front? The squared one, the minus cosine squared. Look, he's negative. You don't want him negative. So move him to the other side, or multiply through by negative 1. Somehow get that in good form. Can you factor that thing? So what, 1 and 6 makes 7. Minus cosine squared minus 6 cosine. And then I'm just going to jump everything to the other side. You could multiply by negative 1, same effect. So it's cosine squared, all the signs change, plus 6 cosine minus 7. Right? Signs are what's in front of them. So that plus in front of the 7, nothing in front of 7, plus becomes minus. So there it is with a 0. Now we factor. Front times front, front times front to be front. Cosine times cosine is cosine squared. Good. To there. And then back times back to make back. What times what makes 7? 1 and 7. But you got to have a positive 1 and a negative 7, or a negative 1 and a positive 7. Can you tell which one it is? Yeah, you got to have negative on the 1, positive on the 7, because you got to make plus 6 in the middle, huh? So you have the plus 7. But if you're not sure, check it, foil it. You go boom and a boom and a boom and a boom, and you'll see it's right. I'm going to go dot, dot, dot. You know the rest from here. Well, wait, but actually, what's that first part going to do? Let me help you. So that's the right factoring, and so then from there, you set this one to 0, that one to 0, so no, this will be easy finish. The first one is 0, which means cosine is positive 1, right? Jump that over. And this one, 0, jump that over. Cosine is negative 7. Can cosine be negative 7?
Nope.
No, sine and cosine are at most 1 or negative 1. They don't get bigger or smaller than 1. This is no answer. Just cross that out. There's no answers coming out of that half. The other half, where is cosine positive 1? Positive 1, that's these 4 dots, 1 or 2 of these 4 dots. Which one of those, or 2 of those, 4 dots on the corners have a cosine, an x value of positive 1? This guy right here, right? 0 degrees. So the answer to that whole problem is 0 degrees. And that's the same radian or degree, right? I don't need to convert that. That's 0. The answer is 0 on that problem. We good there? Questions? And I'll say what I want to say. I'm looking right away, and this is jumping off the page at me. I'm thinking 2x. See, that needs to be a big deal to you. And this is only regular x. They're mixing. That's weird. They're mixing the angles. That's not normal. We can't have that. We got to do something about that. So that needs to jump off the page. That just needs to grab your eyeballs right off the. If you miss that detail and just think it's a regular sine cosine, it's like you've missed the whole ball game. The ball game happened and you didn't see it. That is the ball game on this one. It's identifying that the angles are different. We cannot, must not, under any circumstances, allow different angles. We just can't handle that. We can't have 2x and regular x. They can't be different. If you look back to any of the ones we did last week, when they had 2x, they were all 2x, right? Instead of this would be like 2x. Or if they had 3x, they were all 3x. We never mixed them. That's weird. You can't mix them. We cannot have different angles. We can't mix them. So what do we do about that? We got to make them all. We must make all the same. You can make them all 2x or all regular x, but you got to make all the angles the same. It must be our first order of business. Before I think about anything else, I'm thinking I got to make all those angle things the same. Okay. How do we do it? Yeah, can I replace this? 1 minus cosine 2x? No, there's no such theorem. That's not squared.
Yeah, I didn't realize that.
That's not squared, right? Can't do that. That's not squared. That replacement thing is when it's sine squared or cosine squared that you can replace with 1 minus the other one squared, right? These aren't squared. These are both just first power, aren't they? Well, what do we do? Well, you just got to remember the double angle formula. It'll be on your 3x5 card, but I imagine there'll be a lot. So I made this exam last week. I was noticing there's a lot of formulas in this section of the course, aren't there? Tons of formulas. One of the ones you definitely want to have on your paper is the sine of 2x is 2 sine cosine. See how that changes from double to regular. Do you see the trick there? That's from last section or the section before, I can't remember. Anyway, the double angle formula. The sine of a double angle is 2 times the sine and cosine of the regular angle. So the double, right, very neatly there. It's the double angle formula. It's the double angle formula. So you just got to have it in your 3x5 card, and that's where this is a hard section. It's got to occur to you, and you go, oh, that'll do it. What will that do? That'll change from 2x to regular x, which is what we want to do, right? We've got to make them all the same. So you put that in right there. So this becomes, whoops, got to put the 2 in the front, huh? This becomes 2 sine regular x, cosine regular x, and the right side hasn't changed. But now they're all just regular x. Everybody see that? We can't, so we got rid of the mix. We handled that. We made them all the same. They're all just regular x now. Now we can go back to business as usual. So let me let you do that. Do your next step. Still a little weird. Still not easy. Got to recognize that they both have something in common. Now they both have a cosine. Remember this one back here? When I looked here and I said, oh, these guys both have a sine. I'm going to factor it out. But first, you got to have a 0. See how it's like that one now? Where the two pieces both have something they share in common. So get a 0 on the right side and factor out that common element. So you had to look, oh, look, he's got a cosine regular x, and he's got a cosine regular x. Oh, I'll take him. This is all one term, right? There's no separator in between. They're not separate. They are one, right? Does that make sense? When there's no pluses or minuses between them, then they're one term. Jump that whole term to the other side so you can get a 0. Whenever you do the factoring, you first get a 0, don't you? And then you factor. So that'll make 2 sine cosine plus root 2, right? Because I change the sign when it jumps over, right? And now, see how they both have cosine? So you put that in the front, put one big, remember, take out what's in common, put one big parenthesis. Can you finish it from there? See how when they have a common element, I take it out. It's GCF factoring. Remember that from your algebra days? Two terms have something in common. You put it in the front. How we doing? It's okay? Comfortable with this? Anything I can say to help? Cosine times what? We'll go back to 2 sine cosine. 2 sine. And cosine times what? We'll go back to root 2 cosine. Just root 2, huh? Everybody see how I factored that? I just asked myself, what would re-multiply correctly? That's all factoring is reverse multiplying. It's all factors. So I'm just asking, what would multiply? You know, what times what would work? Cosine times what? Well, times 2 sine would go back to 2 sine cosine, right? And cosine times root 2 would go back to root 2 cosine. Make sense? See how when they have something in common, that's when I put it in the front and do the 1 parenthesis instead of the 2 parentheses. Or put another way, I do the 2 parentheses whenever I have 3 terms instead of just 2. Is that more helpful? Everybody see that? See what I'm talking about? See how there's just 1, 2 terms here. There's not a third term. There's not like a plus 3 off to the right or plus 5 or whatever. There's not a third term. Whereas back here, yeah, look at this one. I'm erasing. 1, 2, 3 terms. That's when I do the 2 parenthesis factoring. Everybody seeing the difference? When you have 3 terms, you do the 2 parenthesis factoring, don't you? Whereas if you just have 1, 2 terms, right? The plus is the separator, 2 terms. That's when you say, what do they have in common? Put it in the front, 1 parenthesis instead of 2. Remember some of that from algebra? So now what do you do from here? Same thing. The first part is 0, or this part is 0. So cosine alone is 0, or 2 sine plus root 2 is 0, right? You say this part is 0 or that part is 0 because they're multiplying to be 0. So then do the unit circle for cosine 0. Move this over. 2 sine is negative root 2 divided by 2. So sine is negative root 2 over 2. Draw the unit circle and find out where that is. We good to there? Then you just do the unit circle thing. Questions on that one? Okay, so cosine 2x minus 11 cosine x plus 6 is 0. Give that a try. What do you notice right away about this one? What's your thinking?
2x and x.
Yeah, that's right on. That's the big problem, right? Got the 2x and x. We just can't have that. I'm not even thinking about factoring or zero or anything but that right now, right? That's my first. I've got to get that handled or nothing's going to work. So I've got to say, okay, I just cannot have that. I cannot have a mixing of angles. Just nothing's going to work. So what do I do? Well, I do what I did sort of on the last one. I got to replace this guy with one of the double angle formulas. But this is cosine. The last one was sine. That one's easier. Let's go back. Oh, it's right here. Huh? Right here. This formula is easier. Sine 2x is 2 sine cosine. What's the cosine 2x formula? Well, there's a couple of versions. Let me show you what you should put on your 3x5 card. Cosine 2x is a couple of different things depending on what you're needing to do at the moment. It is cosine squared minus sine squared. That's true. Or it is 1 minus 2 sine squared, or it is 2 cosine squared minus 1. Is that right? I think that's right. 1 minus cosine squared. Yep. Okay. So there's 3 different options that they gave us back in the double angle, thing for cosine. 3 options for cosine 2x. And how do you know which one's right? Well, right just means which one would be most helpful to you in the particular problem you're looking at. Well, what do I mean? So I'm going to replace cosine 2x with either cosine squared minus sine squared. Do I want that? No. Look, the other one's cosine. It would be easier to just replace it with pure cosine. Do you see what I mean? Then I'd have all cosine. So I'm going to use the bottom one. See how the bottom one's the best one for me in this situation? Because my other piece is a cosine piece. So I'd rather just get everything in terms of cosine. So that's what I'm going to do. Replace cosine 2x with 2 cosine squared minus 1. And then bring down the 11 cosine x plus 6 is 0. Everybody see that? So cosine 2x, I just replaced with 2 cosine squared minus 1. That's great, because now everybody's just regular x. See how that changed it from 2x to regular x? And they're all cosine. Perfect. That I can do. Can you take it from there? It's all about get a 0 factor now, right? We've already got a 0. So let me, we better move on. So let me just jump in and finish this real quick. So then 2 cosine squared, I was going to put it in order, right? Cosine squared, cosine. And then negative 1 plus 6. That's plus 5, isn't it? And then factor, I'll just show you. You just got to factor and FOIL until it's right. I'll just show it. It's, yeah, it's like that. And so, it's 2 cosine minus 1 is 0. And then bump it over. divided by 2, cosine's a half. Bump it over. Cosine is 5. No way. No answers out of that half. Just do the unit circle for the half and you're done. Is that okay? Anything I can answer on that? Is that making sense there?
Where's the scaly ones?
Are there some? Have you looked at them already? Yeah, I better get there. Huh? I know, 20 minutes. I just hate to move on, make sure everybody's okay. But yeah, so remember then, let me just re-emphasize the main point. When you're dealing with cosine 2x, there's 3 options. Put those 3 on your 3x5 card for sure. Put those 3 options. I'd encourage you, even as we go through, to have a little paper where you're going 3x5 card as you go. 3 options for cosine 2x, whereas going back, what did I just hit? Why does it keep doing that? Go back here to sine 2x. There's only 1 option. We just always use that for sine 2x. All right. Okay. So sine x cosine x is minus root 2 over 4. All right, well, this one's a problem. It's got mix, got sine, got cosine. Yeah. I think we need to square both sides. Yeah. We need to square both. So how do I know? Well, I've just done a million of these, and I reviewed them last week, or I wouldn't have. Hadn't done them for a few years. But, I'm just looking at what's leading my thinking is I'm looking and I'm going, we can't have a mix, sine, cosine. You don't want to mix. That's weird. We can't, and they're not squared. Yeah, okay, that's the other. Yeah, let me key in. Because okay, we can't have like sine and then we can't have a mix. I mean, how am I going to factor that? There's nothing in common there. Can't have a mix, and I'd like to replace. That's what I normally do when there's a mix, right? We got some sine stuff, some cosine stuff. You replace one of them, but remember, we can only replace the squared, not the regular sine. Sine squared can be replaced with 1 minus cosine squared. Or vice versa, cosine squared can be replaced with 1 minus sine squared. You can replace squares with squares, not regular sine or regular cosine. So I'm thinking, make it a square. And there's a root on the other side. That seems to agree, like, yeah, we square roots a lot. That's something we often do. Yeah, I'm sure that's the way to go. Does that make sense, how I've arrived at that conclusion? I'm looking and saying there's a mix of sine and cosine. Can't have that, got to replace, right? There's a mix of sine and cosine, so we must replace, but only allowed to replace sine squared or cosine squared, not regular sine or cosine. So second power both sides. So second power, oh, I'm just scribbling all over the place here. So second power both sides. That's that's my thinking. So I go, okay, got a second power both sides. So take this side, go 2 power, this side 2 power. Now having said that, do you know there's something special that must be done when you second power both sides? When you second power both sides, you must check answers at the end for false answers enter the scene. It's probably not something you've thought about before. It's probably a new thing at this point. If you ever use the technique of second powering both sides of an equation, it's a valid technique. Well, technically it's not valid. It's not valid in the sense that it can bring in false answers. It can bring in false answers. What am I talking about? Because, just think about, let me give you just a real simple equation. Whoops, that's not the one I want. Real simple equation. X is negative 3, for example. Okay? X is negative 3. If I take X as negative 3, and I 2 power both sides, I get X squared is 9. There's 2 answers to X squared is 9. What 2 answers could you plug in to make that true? Plus 3 or negative 3. Either one squared is 9. But that was never the answer to the original. See how I brought in a false answer? It was x was just negative 3 from the beginning, not positive 3. Can't suddenly say it's positive 3. So that's just to prove to you that when you square both sides, basically you bury signs, because if you square a negative, you make it positive. So what I'm saying is, whenever you use the technique of second powering both sides of an equation, which we're about to use, it's all we got. We got to do it, but it's a shaky method. You've got to check it. It's like having a friend that doesn't always tell you the truth, right? Hey, he's my buddy. I like him, but he lies sometimes. You got to watch out. Just how it is. I went to a tennis tournament on Saturday. It reminds me of when I played tennis. We had a guy in our team, and he was just a cheater. And so we'd be out at I played at junior college up at Sierra Junior. So we'd go to some other school, and we'd be playing, and we'd all be playing our individual matches, and then we'd hear from his court complaining and yelling and the desire to have coaches come over and call the lines, and we'd all think, Kevin's cheating again. We just knew it. I mean, I liked him and everything, but he was a shady guy, and he just cheated. And anyway, it's like if you have a friend that is a liar. So this method is a liar. When you square both sides, it will bring in some true answers and some false answers. So you've always got to be watching it. All right, second power both sides there. But remember, he's a liar, so we're going to have to check him at the end. So what do we get? Sine squared, cosine squared. Square that right there. When you square that side, what happens? When you square the root 2, plane 2. When you square the 4, 16, and the negative goes away, becomes positive. Just buried a sign there. That's how it can lie a little bit. So 2/16, good there. That's weird. I hope this works. I think it will. All right, well, let's keep going. All right, so now, we good to there so far? Now, replacement time. We're going to replace this one or this one, doesn't really matter which one, with 1 minus the other one. Right? We can replace. Yeah, Rudy.
Do you reduce the 2/16?
Oh, yeah, sure. Yeah, we'll do that. 1/8, yeah. Okay, so let's replace cosine. So it doesn't matter which one. 1 minus sine squared. We good to there? So I just replaced cosine squared. That's why I wanted to get that square in there so I could do the replacement. Remember that? Sine squared, 1 minus cosine squared, or vice versa. So now, distribute. Sine squared minus sine to the 4th is 1/8. Everybody say, I just distributed. Sine squared times 1 made sine squared, sine squared, sine squared made sine to the 4th. Good there. Now what? Now we got a factor. It's a higher power factor thing. So let's do it. I'm just going to go to a fresh screen. I think it'd be easier. So we get to there. I'm going to get sine squared. So what number is this? This is number 11. So
I have a question.
yeah.
Because on the homework, it's kind of showing you a little different way, but
Uh-oh, am I doing the wrong method? What's it showing?
but it doesn't have a root on top. It's showing me to multiply the denominator. Right here. How it's negative root 2 over 4.
Oh, they're probably right. I know, I see. And get 2 sine cosine and replace that with sine 2x. And, oh, yeah, that probably would be easier.
That's what it's showing.
Sorry, guys. I mean, yeah. Never mind. I'm sorry. Yes, no, Chanu is right. I mean, this method might work, but it's looking messy. No, sorry. Yeah, no, sorry. Let's, yeah, see, these are hard. These are even hard for me. I was just trying to demonstrate how hard they are, even for me. Let's go back and try again. No, you're totally right, Chanu. That's a better way to go. All right, forget about all that sine squared stuff. I think in a minute we have to do, anyway, whatever. So, yeah, let's go back. 2 sine cosine. This is a tricky one. Yeah, so what I should have occurred to my mind is if I can just make this 2 sine cosine, I can replace it with sine 2x. Remember that theorem back here? That's what they're doing, and that is a way better way to go. Right here, remember this theorem? Sine 2x is 2 sine cosine. So if I could just make that left side, just multiply by 2, So I'm not going to multiply by the denominator. That one must have a 2 in the, did that one have a 2 in the denominator?
Yeah.
So it's not just always the denominator, it's 2. Because you want to make this 2 sine cosine. Why is that so great? Because then you can replace it with sine 2x and you only have one trig function. And it's way better. Does that make sense? So let's go back to it. So, forget that ever happened. All right, go back to here, and you're thinking, oh, if I could just make this 2 sine cosine, I could replace it on the next line with just sine 2x. I'd have only sine, and then I could do it. So can I make that 2 sine cosine? Yeah, just multiply both sides by 2. So again, it's not the denominator. It's not 4, in other words. It's by 2, because that'll make 2 sine cosine. So what happens over here? This 2 over 1, 2 goes into 4 2 times, you get minus root 2 over 2. Yeah, this will be way better. Like that, we don't have to bring in the liar, we don't have to do any of that stuff. All right, get to here. Probably wouldn't have even worked anyway. All right, we get to here. Now it's easy. Now you might think, yeah, but Mr. Aaron, you said, you might wonder, I don't know if you're wondering, we can't have the 2x. Well, actually, no, the 2x is fine. I said you can't have a mix. So you can't have a 2x and a regular x. I don't. I just have a 2x. That's fine. If you just have a 2x everywhere, and we only have one place, or just a 3x, or just a, that's fine. You just can't, what you have to avoid is the mix. You can't have a 2x and a regular x. I don't have that. I just have a 2x, so that's fine. So what do we do from here? We do the unit circle, and we say, okay, where is sine negative root 2 over 2? That's negative the medium. That's the medium one, isn't it? Sine is, oh boy, look at the time. All right, it's right here and it's right here. Are we good with that? The two medium, because remember, sine is down. It's the y value. This has a negative medium y value. So this is 180 plus 45. This is 225. This is 270 plus 45. This is 315. So 315 and 225. Got to change those to radians. So 225. I'm just going to change those to radians. Well, I'm going to save time. What is that? 1, 2, 3, 4. That's 5 pi over 4. One quick way I do it, I don't know if you're comfortable with this at this point, is I just count pi's over 4. This is pi over 4. Do you realize that? 1 pi over 4, 2 pi over 4, 3 pi. For halfways, you just count pi's over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, see, pi, and 5 pi over 4. So you can, if you want to speed, I'll start giving you some speed up techniques now if you want to just grab radians quick. So for the halfway angles, just count pi's over 4. 1, 2, 3, 4, 5 pi's over 4. 6, 7 pi over 4, right? There we go. Got them as 2 radian angles. 5 pi over 4. 7 pi over 4. Now, am I just done? Boom, there's my answers? No, I'm not. I can't stop here. Why not? 2x, remember? If you have a double angle, you have to write 2x equals that plus 2 in pi. We've been getting to avoid that for a while, but here it is again, rearing its ugly head. Everybody see that? When you have 2x or 3x, you can't just do your 2 answers and done. You have to write 2x equals, and then you have to add the 2 in pi there. Remember all that? I'm going to go to a fresh screen. This one's not done. So 2x equals, what is it? 5 pi over 4 and 7 pi over 4? Plus 2 in pi. Plus 2 in pi. Good, everybody good to there? So now, what do? Remember, you have to do a couple and then divide. Remember the whole thing? You got to let n be 0, n be 1. Remember the various cases? You got n 0. Well, in that case, you'll have 2x is 5 pi over 4 plus 0. So it's just 5 pi over 4. If you let n be 1, you'll get 2x equals 5 pi over 4 plus 2 times 1 pi. So I'll let the n be 1. Right? Now, what's that? Well, oh, no, let me back up. Let's divide by the 2 first. I'm sorry, I keep changing my mind. The easier way is to divide by the 2 first, isn't it? Let's divide by the 2 first. Remember? Yeah, that's what I showed you, huh? That is easier. So divide through by the 2 first, and you get x is 5/8 pi plus n pi. Everybody good? Same thing here, divide by the 2, which means stick the 2 in the denominators. X equals 7/8 pi plus n pi. Now let your n be 0, and you get x is just 5/8 pi. Let n be 1, and you get 5/8 pi plus pi. That requires common denominator to combine those, right? So that's 8 pi over 8. That's 13 pi over 8. And let n be 2, and it's not going to work. Because 5/8 pi plus 2 pi, if n is 2, that's 2 pi plus more. That's more than 2 pi. No, they said not to go beyond 2 pi in the original thing. So we just do n equals 0 equals 1. Same thing over here. I'll do the other side. N equals 0. You get x is 7/8 pi. N equals 1. You get x is 7 pi over 8 plus 1 pi, which common denominator, make that 8 pi over 8 pi. X is, what's that, 15 pi over 8. So there's our 4 answers. 5/8 pi, 7/8 pi, 13/8 pi, 15/8 pi. So remember, you got to do that whole 2n pi thing when you have a 2x or a 3x, right? Remember all that? Sorry, I messed that one up. We wasted some time. So the trick on that one was seeing that sine cosine and thinking I need 2 sine cosine, and I can replace it. See, these are tricky. I forgot about the calculator ones. So hit the buttons. Sine x is 0.3232. Just hit sine inverse. Make sure you're in radian mode. Make sure you're in radian mode. On your calculator, hit sine inverse of 0.3232. Somebody got an answer for me? Sine inverse? What? 0.329. Anybody else getting that? Good. There it is. Oh, that's not the only answer. That's one of the answers. Okay. Yeah, here's the trick on this, guys and gals. I wish I had more time. You have to find this in 2 places. Remember, because these answers on the unit circle are always in 2 places. On these calculator ones, well, how do you know what 2 places? I mean, it's not one of our small, medium, large, right? Just find the 2 quadrants. What 2 quadrants? Well, where is sine positive? That's a positive 0.3232, right? Where is sine positive? The original question is sine is something positive. Well, where is sine positive? All students take calculus. So which 2 quadrants? Everybody's positive in the first, and this is the first quadrant answer. That's the first quadrant. Okay. Well, where's the other answer? It's in the second quadrant where sine is positive, huh? The other one's in the second. Well, how do you know what it is in the second quadrant? It's going to be the same reference angle. The same reference angle. Now, what's a reference angle? Remember, that's been a month, probably since we talked about reference angles. Reference angles come off which axis? X-axis. Because that's where 0 comes off. Remember, we all start this from 0? So when they say 0.329 in the first quadrant, they mean 0.329 off the 0. So you likewise do 0.329 off the x-axis in the second quadrant, because there's a sine answer in the second quadrant. So you come up 0.329 from the x-axis. That's what a reference angle is. It's from the x-axis. No, it's not from this y-axis here. Always from the x, huh? So how do you know where that is? Where is this right here? If it's up 0.329 from the x-axis. Well, this is pi. Radians, isn't it? Remember? Because it's 180. So it's pi. So we're asking, what is this angle? Because that's how you say the angle. From 0 to there is what angle? Well, it's the same reference angle. So it's 0.329 up from the pi. Right? So now there's all the way to here is pi. Back up 0.329. So it's pi minus 0.329 is the other angle, is the other answer. Hit the buttons on your calculator. What's pi? You got a pi button, right? What's pi? Because you got to use more than just 3.14. You got to use more. Actually, you got to use that pi button. 2.81. How many places do they want here? 4 decimals. 8124. Did it round? What was the next one after that?
8.
Oh, so 8, so that it'll round. 2.8125. Oh, and this one I needed more accuracy than 0.329.
3.291.
Oh boy, I knew I wouldn't make it. I can't believe it. So, all right, so I'm going to have to finish this. I don't know what I'm going to do because I got to get the price down. All right, 3.5. Let me hold it off. It'll be due. Yeah. Yeah, I'm going to have to make it. Yeah, sorry, I'm going to have to make it due Wednesday. Maybe I'll throw up some more YouTube information on this. Yeah, sorry. It was hard to finish.